Okay, my friends, here's a quick little extra for the ArabinoseOperon. Ooh, creepy. Alright. Okay, so we're going to do a little activity again with the ArabinoseOperon. Now remember, I'm going to remind you guys of how it really works. You should have just watched the other lecture capture. If you didn't, go back and watch it. Right, the ARA-C protein, always made. This is constitutively active, control or regulatory gene. Right? If there's no arabinose sugars around, so let's pretend like these don't exist, then this guy binds to the initiator complex, and that all causes looping around, and it also binds to the operator. That blocks transcription, no transcription. If this guy does interact with this guy, then he just binds to the initiator, and RNA polymerase can come in with sigma factor, bind, and get transcription yes. So our question is, what happens if we change or mutate something in here? So if we mutated the initiator sequence, delete it or totally mutate it so it doesn't work, what happens? Right? Transcription or not, that's always our question. So what do we see? Well, if the initiator sequence is not there, this guy has nowhere to bind, right? And the binding of him, in this case, actually recruits in RNA polymerase sigma factor to do transcription. So without the initiator, without some binding of this guy, right, with arabinose, we don't get transcription. So if this is a mutant, that equals no transcription. Okay, do you understand that? Because the ArabinoseOperon needs something bound to activate, right? ARA-C plus arabinose activates, gets RNA polymerase there to go. Or ARA-C protein by itself interacts with the initiator and the operator, causes that weird looping out and blocks transcription. So without this initiator, no transcription no matter what. Kind of like without the promoter in either the lac operon or the trip operon. Well, what if we mutate the operator? So now the operator does not work, mutant, and we have the ARA-C protein as usual, always made, and arabinose is accessible. So we will make this complex, right, with the arabinose, and then RNA polymerase and sigma factor can come in, and yes, we get transcription. Okay? Because there's no, right, that doesn't matter. But what about if we mutate the operator and there's no arabinose available? What happens? Well, let's take a look. This guy can still bind here at the initiator, right? And he's supposed to then also interact with the operator to block transcription. The operator's not working. It's a mutant. Nothing can bind there. So what happens? Yes, transcription. Even though it's not supposed to. It's only supposed to happen if arabinose is there. But because of this mutation, changes the outcome. So our question here is, what if we actually clip out the operator and move it downstream, or excuse me, upstream of the control gene and its promoter? So let's draw that out for you. Right, so let's pretend this whole thing now is the initiator, right? There's no operator there. This is all that initiator sequence, and the operator sequence is now here. Okay, what happens if we move that guy there? What happens to transcription with arabinose present and without arabinose present. So draw what you need to draw, answer these 2 questions, number 1 and number 2, transcription or not, take a screenshot, upload to our Arabinose homework, and see you next time.